Such an honor to be here, and remember fondly all of my years of teaching statistics in grad school, and I'm just really excited that so many folks here are interested in data science and interested in what we can do to train people to appropriately apply what we've learned in statistics field to this kind of emerging field of using statistics, using machine learning much more in kind of like the world we're creating. And so, yeah, so without further ado, I just want to introduce the topic, which is sort of the things that I have learned from transitioning again from this more kind of traditional application of statistics in the medical field in biostat, coming from a school of public health and specifically working on genomics, into the tech field, into essentially a product, a service that relies primarily on the use of algorithms in order to understand how we connect clients and clothing, and how we can understand people via the information they give us, the surveys they answer, the ways that they engage with our products. So so I am going to share my screen so that you can see my presentation. So yeah, first a little background on me. So like Megan mentioned, I came from this PhD in biostat, and sort of I have here from high school onward. Went to a high school where I was very much a math and science nerd. Moved to Pomona College, such a great school. Loved my experience there. Loved my statistics teachers, Joe Harden in particular. And so, yeah, gained a lot of love for the field there. Went on to Johns Hopkins, where I got my PhD in biostat, working in genomics. And then I've sort of tried to visualize here a left turn, where after that I went into the tech field. And so, and kind of started to get job titles that were more and more fuzzy, but involved data. So at Etsy, which is an online marketplace for handmade goods and craft supplies, and probably more now. It's been a few years since I've read their tagline, but at Etsy, I was a data analyst. And so this is a person who helps evaluate whether or not we're building the right experiences, if we decide to change the way that the search algorithm works, or we decide to totally change the layout of the shop one way or another. You want to measure that and understand if that change was a good idea or not. Around that time, I also started this Not So Standard Deviations podcast with Roger Pang, who is a professor at Hopkins. And that's been really rewarding work, totally unexpected, another kind of left turn where we've been able to discuss statistics, how statisticians work, how data scientists work, and kind of had this opportunity to evolve ideas over time so that to really kind of like understand, how is this work different? How are these lines of work the same? And what is this field missing? What sort of training are we missing in statistics and in traditional fields to prepare people for this career path? So I was at Etsy for about 3 years, and then I moved over to Stitch Fix. Moved to San Francisco. Etsy's in Brooklyn, so did the full cross-country thing. And at Stitch Fix, I've worked on a variety of teams, but always focused on the same problem, which is what data should we collect from our clients in order to serve them well. And the idea here is that, when we're talking about recommending clothes to people, we need to understand things about them, like what sorts of colors do they like, what sorts of styles, what size are they? There's a bunch of things involved with what makes a person buy a piece of clothing. And so it's been really fun to try to explore all of these things and get into like, what does it even mean for you to like clothes? Like, how are you expressing your identity? How do you articulate that? It's very nonverbal. So it's been really rewarding work. So the theme here, it's kind of like the beyond art and science. The theme here is what I feel like a gap in our training and our understanding of the field in general is. And this gap, just to kind of lead with the conclusion, is this concept of design thinking. And so I'll get a little bit more into the details of design, but for those of you who might not have a lot of exposure to like kind of that field, which I certainly didn't coming in, the idea is like, these are the people who are coming up with the material, anything that isn't like a tree growing, the natural world had to be created and essentially designed. And so, buildings, clothing, systems, even data analyses, they have to there's nothing there and you have to make it from nothing. And so that is a field that's sort of emerging. There's been a lot of kind of academic thinking and I think since about the 70s, kind of like a coalesced into a academic discipline. And so as I've gotten more and more exposure to this thinking, I've realized how important it is for statisticians and data scientists to utilize what has been learned in more traditional design fields like architecture, and apply it to how we architect data analysis or how we architect a new recommender system. So another alternative title is kind of things you'll need to do your job well that no one else tells you. And I really should say a data scientist needs, since I know not everyone here is a data scientist. But I also do think that this applies to every part of statistics. And so it's kind of like we focus so much on math and science and proving things and, kind of going through examples, but there's a lot of this, how do you negotiate creating new things in a context? How do you make sure that you're making the right analysis for the right person so they can make the right decision? And that's just really hard to teach. And so I want to offer some suggestions for like examples and suggestions for how to do that. So here I have kind of, I don't know if famous is the right word or notorious, but certainly a paradigm for doing data analysis that's been put forth from Hadley Wickham and sort of the tidyverse, the sort of R, the statistical programming language, like that paradigm. And so the idea here is like, if you kind of think about how data analysis happens in a very simplified way, you have a data set that's been collected for whatever reason. You import it, you have to import it technically into a session. And then there's concept of tidying, which is just, making the data into a format that makes it analyzable. And so you might have, you might have a format where it's like from an Excel sheet and it's, you have things coded in colors of the Excel sheet, or it's just like, things that you need to get into, readable format at all. Or there's things like, oh, this data is structured in a way that's not super helpful. And actually, if I rearrange it this way, I might be able to analyze it a little more easily. So it's kind of that whole process of getting the data into the shape you want it. And then you sort of enter into this cycle where you're taking that data, you might do some sort of transformation such as a model, linear model, binning things into categorical variables, like any number of the kind of tricks we have up our sleeves for doing data science. And then you'll visualize those results. And then I guess I should say with transform, well, you visualize those results and then you might model those results, transform the model results into, summary statistics, visualize. So I haven't articulated that perfectly, but the idea is that this is kind of the dialogue that you have with the data that allows you to start to come to conclusions and start you on the path of creating what will ultimately be kind of a narrative around what you've learned from this data. And then you sort of like, once the narrative starts to coalesce, you sort of exit this kind of cycle, and then you start to really focus on communicating that out to your stakeholders one way or another, whether it's collaborators, whether it's students. This is a key part of a data analysis, is getting it out to other people. So what I've seen in the field is that this middle part where you're doing this kind of dialogue with the data, people view that as the fun part of the job. It's like, oh, okay, got the data into the session and now, I ran this model and what did I see? And it's a really fun, playful space where you're starting to generate insights and, things are going off in your head of like, oh my gosh, because of this, I think that hypothesis might be true, and let me look into that, and oh my gosh, and it's all very nonverbal, but it's a very fun part of the job, and I think it's why so many people get into it. And then there's kind of this idea of like, oh, tidying the data, so like actually getting it into the readable format is not the fun part. And then also it happens to be a huge part of the job, right? And so that's just sort of an interesting thing we have in the field, where we talk about this kind of fun part, but then when you talk to people who are out in the field doing data science or doing statistics, applied statistics, they're like, oh, that's actually, though, I spend way too much of my time like cleaning up the data one way or another. And then if you really zoom out, and this is a part that I think across the board, data scientists and statisticians, we have a real tendency to just say, here's the data. Like, we already have the data set, here it is. And now, ooh, you have to change the format. And then, ooh, finally you get to do this fun part. But actually, the process of collecting data usually is the most time-consuming part when you think about it in the grand scheme, because you're talking about people going out and doing surveys, or like designing a measurement device that might take, air pollution levels, like getting someone out into the field and getting them to set up the device, and quality assurance of the device. Or in a tech setting, it's like building the website that you're going to collect data from, or in Stitch Fix's case, it's like, what surveys do we ask, and what sorts of things do we collect about users' reactions to their clothes? And so now we're talking about like the fun parts, this tiny little part, and actually, the bulk of the work that goes into getting that insight is things that we don't spend as much time formally teaching. And so this is where kind of the design starts to get in, and where I've seen the most rewarding work I've done, the most high impact work I've done, is actually in thinking about this whole system instead of just that kind of fun part at the end. And so again, when I'm talking about design, I mentioned that this is this academic field that I've gotten more and more exposure to. So these are some of the resources I've leaned on. Nigel Cross is a professor emeritus from, I can't remember, I think it's Cambridge or University of Edinburgh, but he is like one of the founders of this field and spent a lot of time kind of defining this as its own unique kind of academic way of thinking that's different than, kind of the two that we usually have, which is art and science. I also recently came across this book, How Design Makes the World, where this is just someone really clearly laying out for a non-designer audience exactly what do we mean by this field. I so highly recommend that book. Like, that was a photo I took when I was 24 pages in, and there were just so many insights that really directly apply to data science when you start to dig a little more deep into the challenges that we have as a field. So again, so I thought a lot about it, and, just like very simplistic, what does a designer's daily life look like? Usually there'll be something like, oh, there's a chair. People need chairs, obviously, in all sorts of settings. And you might have some sort of client who's, has an auditorium, and they have, maybe plastic chairs, they have, some chair, and they need to get more people into the auditorium. And so they might say, okay, they go to a designer, they say, hey, we need more people. Can you make a more compact version of this chair so that we can get more people in the door? So that's sort of, already the analogies to data science and statistics come up, where it's like, you have someone you're working with and they're asking you for a very specific thing. In our world, a lot, it comes down to like, hey, can you get this number for me? Can you look up the number of clicks we had on this one feature on the website? And then as statisticians, I'm sure that resonates, where it's, collaborator coming and saying, hey, I need to see XYZ from the project we're working on. And I think we all know that's one of the most draining part of the job, is just feeling like you're kind of like getting numbers for people without being asked to think critically. So zooming back to Stitch Fix a little bit, I wanted to give some examples of what I mean by designing this entire system. So again, Stitch Fix is this personal styling company. Your client experience right now, although we're actually in the middle of evolving this a lot, but the one I want to focus on is our most core traditional product, which is that you sign up, you take a survey that's several pages long, and we ask you all sorts of questions about yourself, like your kind of vital statistics, like how tall are you, what sizes are you, and then more fun stuff like, hey, of all these kind of 12 outfits we have, which ones do you like, which ones do you not like? And then we ingest that information, and there's a human stylist involved. So as a client, you kind of create this, and then we're like, okay, we're going to send you a box with 5 items in it. They're going to be handpicked by a stylist, and then you can try them on at home, keep what you like, and send back the rest. And so that's what your client experience is like. And then at the end, once you've received the item, you can give a bunch of feedback for, did you like it? What was the size? Was it the right size? Did you like the style? Did you like the fit? And we kind of have these drill down questions if you click on specific issues that you can see there in the blue. Things like, oh, actually, it fit okay, but the shoulders were a little tight, or, things a little more specificity, like the sleeves were too long, the types of more detailed fit challenges that we can use to better understand exactly what clothes we should send you. And so what's happening behind the scenes and where we get involved is that, we have this like pool of inventory. So all these items, we have in our warehouses available to be purchased by people. And then we kind of take that, we take the client information, which I mentioned before. We do fancy machine learning and statistics, which you can see there represented by very fancy looking graphs. And so you take those, and then you get a list of recommendations. So like, okay, for Hilary, here was all the stuff we had available, and here's this ranked list of what we think she'll like best based on the information we have from her, the information we have from the items, and the information we have from people in the past and what they've bought, and are they similar to Hilary, etc. So the real challenge we had in the early days of the organization is that that's a pretty slow feedback cycle. So, for a given person, the kind of highest cadence of clothes you can get is 5 items a month, 5 items every 2 to 3 weeks in our traditional business. So that's a lot of time that we have to wait to get things. And then you can imagine with clothing, it goes in and out of style really quickly. So it's not like, we don't necessarily accumulate much data on individual items before they're like all sold. And so that can be a real challenge in terms of understanding, being able to build these algorithms to actually be reliable. And so when I talk about, solving those challenges, it's like, okay, so how can we actually understand what clients like what items a little bit better? Like, how can we solve this style challenge that we have? And so this I found to be like a really inspirational project from a coworker of mine, Chris Moody, who took it upon himself as a data scientist to figure out a way for us to understand whether or not clients like clothes more quickly than that kind of cadence we were talking about. And so he built an application that essentially shows you a piece of clothing, and you can say if you like it or not. And then it's like a very rapid fire, here's the next one, here's the next one. And so you can kind of just give that instinctual reaction to like, oh yeah, I like that shirt, or oh, I don't. And now instead of getting an understanding of your style over the course of months, we'll get your reaction to, 50 items in a couple minutes a day. We limit it so it's not just like you're spending hours kind of like in a trance state with this app. We want it to be fun and useful, but not like overtaking your life. But it's just by collecting this data, it opened up all sorts of statistical models that we didn't have available to us before. And so some of the things we've learned, for example, are that, kind of we call it like boho clothing, things that look really, like people who love the 70s, my personal style. We saw that as like very kind of opposite, and we did like factorization machines in order to show this, but like kind of if you factorize the data, look at what's clustering together, you see that boho clothing is kind of one, like this is one of the principal components. So boho clothing is on one side, and then preppy clothing with like lots of stripes and colors, bright colors, is on the other side. And so you can totally understand that, where it's like, oh yeah, I can see how these two looks, like there's not a lot of people who encompass both of these looks. Like, one day they're dressed in this kind of super preppy New England way, and the other one is like very much like Santa Fe, like like chilling out at Sedona on the weekends. And so that's just like one of the really cool things that we learned from this this game that was a huge boon to us in terms of the business. So like you can imagine with this information, with knowing what specific clients are rating from their style shuffle game, and then understanding this about the items, it just opened up a totally new line of research that was super important. So the sort of lesson for teaching statistics is that thinking about that whole system and potentially designing new products, which when I say products, I don't mean like clothing, but this is sort of a tech term for user experiences. So you can really think of like designing new surveys, designing new, you know, like experiments that you want to run. So designing that whole thing, including data collection, will give you the biggest wins, will give you the most interesting insights rather than taking an existing data set and trying to squeeze more juice out of it. And this is a really big shift in mentality from what I've observed in the data science world, and I think coming from computer science, like that's just a really big shift in mentality. And so I think it's really important to emphasize that early and often with people. So yeah, again, like this data collection is a really important part. Tidying is a really important part. So I'm kind of like zooming back in here. And now I do want to talk more about kind of this core process. So, you know, I've kind of made my case for like new data is important, but the case I want to make now is like, okay, so yeah, designing the whole system, including data collection is important, but also thinking a lot about how you design the way that you do this actual process of data science is also really important. So your ability to go through this cycle where you're, you know, kind of having this conversation with the data, that is fundamentally linked to what tools you use to do it, and whether or not it's a language that allows you to articulate yourself well, or it's fundamentally limited by how hard it is to get the data into those sessions, or how hard it is to take that data out and make, you know, communicate with it. Like if you're writing reports and then new data comes in and you have to totally redo your analysis and then you're copying and pasting graphs into the report, and then, you know, that's taking up a ton of time. That means that, you know, you've designed a system that is, you're spending a lot of time doing the parts that aren't kind of like the fun part of the job. And that's a really important part of doing this job well, is trying to, you know, create systems where you are as fluent as possible. So I like to think about this as like statisticians, data scientists. We are, whether we want to be or not, we are systems engineers. So we have to take data into some sort of environment, and then out on the other end, we have to create some sort of analysis or insight. You know, it could just be an insight that you're sharing with colleagues, or it could be an analysis, or it could be a recommender system. But, you know, data's coming in one end and something's coming out the other, and you have to design all those steps in between. And we talk a lot about building it. You know, we talk a lot about like, you know, okay, you know you're using R and what's that look like, but we don't talk so much about designing and iterating on what we've built. And so again, getting data from point A to point B with as little error as possible, that's really fundamentally, if you think about what you don't want your system to do. You don't want your system to introduce error or introduce a lot of difficulty for yourself, so that, you know, kind of at the end, you're getting a bad result instead of a good one. So I want to like zoom out and kind of give the Stitch Fix perspective on this again, just so that you understand what I'm talking about when I say, you know, getting data in and having it come out into some sort of analysis, what that looks like within a text setting. So, you know, I mentioned before, a user comes to Stitch Fix, they fill out their style profile. So we might ask something like, this is one of the questions we worked on, of, you know, would you wear these jeans? You know, you have the ones that are super clean. There's some with like some, you know, distressing, and like, you know, get to like, you know, holes in the jeans and stuff. And you can imagine this is pretty polarizing. Some people will never wear jeans with holes, and it's like, why did I buy these? They already look like they're used. Versus, you know, this is like a super trendy look for younger folks, and they don't mind buying jeans with those holes in them. So this is sort of the, you know, the type of thing that we want to get from clients early on, so that we're sending them the right clothes right away. And so in terms of where the data comes from and where it goes, you have a user who might come to Stitch Fix and fill out their style profile. So they're clicking on these buttons and this person's like, yeah, I might wear these. I maybe wouldn't wear this other type. And so at that point, the data is stored in our engineering system. So, the people who've built the website and log this information so that when I log back in, I see the same results. That's all, logged in sort of these engineering systems. And then at that point, the algorithms team actually takes snapshots of those engineering systems and puts them into our own systems. So the engineers are interested in showing things back to Hilary, like, oh, hey, here's the results. Here's what you saw from, here's the answer you gave to us when you first signed up. But then our side is interested in getting that information and then running models on it. So we have to essentially take it and clone it over to our own stuff. And so I put here, there's kind of Hive, S3. These are not, things I actually want to talk about, but I just wanted to illustrate, like, here's the technical tools that we use in order to do that. And then, as a data analyst in one of these settings, you might extract the data from these technical kind of data lakes or whatever the latest term is for that, but you have the data sitting somewhere, you pull it over. And then at that point, you might say, okay, let me import this data into an R session. And now that's where I can kind of start to do my analysis. And so then, I might have my tooling choices, like I'm a, big tidyverse fan and kind of that whole paradigm for doing modelings within R. And so at that point, I've made a choice of like, okay, I subscribe to this kind of paradigm. I find myself to be productive in that. So I'm going to import my data and I'm going to get into a format so that these tools are very fluent for me and that I can use them easily. And then eventually when I want to take that off ramp, I might choose kind of various reproducible ways of making analysis. That might eventually turn into a markdown file. It might turn into a PDF. It could turn into an email to my coworker saying, hey, it looks like this many people visited our site yesterday. But again, that's all like taking data from one place and getting it to the other. And I want to know that that's all working right. And so when you're doing system design, that's actually a very difficult thing. And there is so many, going back the slide, each of these junctures represent a place where error can happen. And where our jobs become most frustrating is when that error is introduced and we've made a wrong conclusion, or, we've run the wrong model, or something, whenever errors happen, that's when we feel like we failed. And so fundamentally, that's what we want to avoid. And so that's where everything just becomes a minefield, right? Because there's this impulse to say like, oh, this person did a bad job. Or I think that the way that people communicate this is by getting really into the tools and saying, oh, you should be using R, not Python. Or like, you should be using this paradigm of modeling. You should be using data tables and not tidyverse. This stuff comes up over and over again and gets so contentious so quickly. And so what I have learned from working with people who are professional systems engineers and are focused in these types of systems, but much more for, keeping websites up or keeping, engineering systems running, is that they have a lot of insight into what works and what doesn't. And so one of the biggest things is focusing on generic principles and saying, okay, let's not talk about R versus Python, but let's talk about what languages allow you to be most fluent when you're doing that analysis step. Is it that you need tools that are really focused on performance because you're working with such big data sets? Or do you need things that really allow you to do analysis quickly and make beautiful reports because you're needing to generate reports all the time? People are going to use different tools based on what they need to prioritize. And so by talking about the principles, that leaves people free to say, well, I really prioritize reproducibility, or I really prioritize speed because I just can't iterate on my analyses unless I have something that's like works super fast with big data. So, kind of some framings I have for kind of teaching students and just in general in this work, how to avoid the contentious discussions. For example, a lot of people say like, oh, Excel's the worst. And, it's like really fun and easy to bash Excel and everyone does it. And so that's obviously not super productive because many, many millions of people find Excel to be where they work the best, right? So if you just say Excel's the worst and you don't say why, you're basically telling someone the way you work isn't right. And you haven't heard their rationale for why they work that way. You haven't heard the pros and cons that they're personally weighing. If you're working in an environment where everyone else is communicating via Excel sheets, and this happens a lot in finance and financial planning, like you can't just have someone like port over to another system without a huge cost to them in terms of communication with other people. And so instead of saying Excel's the worst, like put aside that fun debate, you can say, okay, well, here's my rationale. Like Excel, like the principle that I want is to be able to create reproducible scripts because I need to redo my analysis frequently. So if you want to redo your analysis frequently, writing a script will take time now, but it will save you time in the future versus, kind of having to re-input things into Excel and, remake formulas or whatever. And so by framing it as a generic principle, that can make this conversation go much better. And you can actually start to talk about the system engineering part of it. The other thing that's really important is to notice when your system is failing you. And so one thing from system engineering is like anytime there's a failure in a system, there's sort of this incident-based system evolution. So if you have a website go down, I saw this in action at Etsy, if the website goes down, you need to really document exactly what happened so that you can say, okay, let's change the system in the future so it doesn't fail like this. And so there's a lot of resources around this sort of thinking that I got exposed to first at Etsy when I entered this more engineering kind of application. And I found it to be just so productive and so helpful, and I love applying it to the field of data science. And the idea is kind of this paradigm shift from blaming people to blaming systems. And so the central thesis from this book from Sidney Decker, kind of understanding human error, is essentially that we shouldn't talk about human error. Like it's just not helpful, and it leads to unproductive conversations, and it leads to the same amount of error in the future, because then you can just go from blaming one individual to another. And so what I've seen really successful in lots of different settings is this sort of blameless attitude, where when an error occurs, you assume that the person who was, involved with this error occurring, they didn't wake up that morning and like want this error to occur. If someone like sends out a bad data analysis, they're not happy about it. That's not like what they wanted to do that day. And so instead of saying, oh, that person, like be better next time, it's more like, okay, so the system you were working in didn't help you not make this mistake. So how can we change the system so that the next time you wake up in the morning and don't want to make an error, your system doesn't allow you to make that error. And so a constructive way to sort of respond to incidents is this paradigm of blameless postmortems, where you sort of create like a psychologically safe place for people where they feel like, okay, if they make errors, they don't want to hide them. They're totally comfortable sharing them with people because they don't feel like they'll be reprimanded. And then when you're able to kind of go through these postmortems, I think we all know that quote from whoever it was, where it's like to consult a statistician at the end is just to have them do a postmortem. It's like, okay, so how did that system fail? The researchers didn't want to have their analysis. They didn't want to collect data and have it go nowhere and not generate insight. And so how can you go and change the way that you interact or whatever so that that doesn't happen in the future, rather than just kind of shaming the scientists and being like, oh, you should have talked to me. It's more like, okay, let's come together and let's think about where this system failed us, not have any sort of personal attacks or personal judgment calls, and just say, like, how can we work together better in the future so this doesn't happen? And I think about this a lot too in terms of the tooling. So it's like, when someone does an analysis and it's not reproducible, how do you talk about the way that the system failed without it becoming contentious? And I'm getting a little distracted because my cat just jumped on my lap. So my cat does this frequently when I'm giving talks. So like I said before, that's sort of like, kind of going back to this organizing principle of what data analysis looks like. We just talked about kind of how you design this whole kind of engineering system of getting data from point A to point B. And that is one more application of how you need to use kind of this design mindset and how you need to kind of be able to open up yourself to iteration, to talking about principles. And so the last thing I want to zoom in is this communication aspect, because this is very difficult, obviously, to teach. And I think that this is where we depart the most from kind of one of the reasons that most of us probably got into this field, which is loving math, loving modeling, loving looking at the data and communicating with people about that, is not something we're trained in nearly as much. And I think there's reasons for that, which I'll get into. So again, this is where I go back to this field of design, because like I mentioned before with the chair, like designers are faced with the same issue we have, which is that they get approached with like very prescriptive, can you do X, Y, Z? And then they have to kind of reframe the entire thing and say, okay, what is it this person is trying to accomplish and how can I help them? So before, I mentioned this kind of designers work by, they'll get a request that's like, can you redesign this chair to be more compact? And so what skilled designers will do, and the first impulse that someone would have is just to be like, okay, that's what I'm going to do. And like, let me make this chair more compact. But a skilled designer will be like, okay, let's go to that auditorium. Like, I want to see the auditorium in question. And why don't you, show it to me? And then they'll go to the auditorium, the designer will look at it, and then they might say, okay, like, I totally see the challenge. What you really want are more people in this space, up to the fire code. And so let me suggest some solutions for you. And it might not just be a more compact chair. And, they might suggest something like, well, why don't you install benches here? And that would allow people to be a little closer. I'm just realizing now that this example in our COVID times is kind of like a interesting example. Maybe the design solution is not this. And actually that, like right now we're seeing a lot of design thinking going on around, kind of like partitioning, or how do we create these shared spaces without exposure to viruses, et cetera. So it really is like a rich time for observing design in action. So when you kind of dig into this design literature, what you learn, and what that field has a lot more articulation around, is that reframing a problem is actually a really big part of the solution. And so the question is not just like a designer, it's like a very, it's part of the training to talk about the fact that people come to you with these prescriptive solutions where they're like, okay, someone is going to come to you and ask for a more compact chair. And so there's sort of an acknowledgement and training within the community for like, okay, so how do you zoom out and not have that conversation? How do you change the conversation to something else? And so what I love about reading Nigel Cross, which I really recommend for this group since this is like an academic group, that he does so much talking about where design does provide value and where it is this kind of different way of thinking. And this reframing is like actually a pretty big cognitive task. Like it requires a lot of creativity. It requires a lot of understanding in order to take a problem and zoom out and think about it another way. And if you reframe the problem correctly, the solution seems obvious. Like if you reframe that problem about compact chairs as getting more people into an auditorium, then like benches just pops up as the solution. But reframing it, that's a very simple example, but reframing it is really like, that's where a lot of the creativity comes in. And as statisticians, that can be, someone came to you with a very specific request and you come back to them with like a very elegant solution where you say, hey, okay, we're going to answer the question that you it seems that you want answered, but we're going to do it in this totally different way. And here's the data we'll need to collect, and here's the analysis we'll need to do, but we'll get the answer. And that's where kind of the brilliant, the aha moments for people come in. And so when you think about like what it means to, what it means to be able to zoom out and talk to someone about this reframe problem, there's really two key fundamental things you need to understand. And again, this is not what we would usually talk about in like a statistics conference. But the first thing is the fundamentals of the system you're working with. So in the example with the architect, working on compact chairs, it's like you really need to understand every aspect of what it means to have an auditorium. and, what are people comfortable with? Like that COVID example is a great example where our definition of what people are comfortable with in an auditorium has drastically changed. And so if you're kind of not tuned into that, you don't really understand the way auditoriums function, and you don't understand it in the future, you won't be able to come up with creative solutions because it'll be like totally foreign. And, you can't necessarily, if you don't understand the system you're working in, you're not going to be able to understand what sorts of like reframing that you can do in order to come up with solutions. And then really like one of the biggest parts of this is understanding the person that you're talking to in a very fundamental way. And so with reframing the auditorium thing, someone's come and they said, we really need more compact chairs. And so what you need to understand as a designer is like, okay, who's asking this person to, make this solution happen? Like, is this person getting a ton of pressure from a higher up that they have a big conference in 2 weeks and they really need everyone to be in an auditorium? Or are they getting a ton of pressure because COVID just happened and they need to redesign things so that their company can start making money again? Like these are the types of incentives and pressures that you need to understand about a person coming to you asking for a solution so that you can work with them on the right solution. And, if you only understand the system, you might come up with this brilliant solution, but to the person you're working with, it won't solve their problem. And so you'll get tension and you'll get a lot of talking about like, no, that's not good enough. The benches aren't going to work. Like you can get really caught in a cycle doing that instead of like getting, like you could avoid that cycle if you just understood where the person was coming from. And this manifests in statistics a lot because people, it comes down to like the nitpicking you see where, you've done an analysis and then someone's like, can you look at this? And it's like, okay, let me look at that. And then they're like, can you look at this other thing? Or like, I don't really believe that. And it just turns into this can be very toxic where people are going back and forth. But almost always if you zoom out and you understand, okay, why does this person care so much about this segment? Like, why are they pushing on it? And you'll usually be able to follow that chain of whys to some sort of incentive system they're working in that, you like are never going to get out of. So we've talked about this a lot on the podcast, and Roger Pang, my co-host, wrote up a really brilliant sort of long blog post that I've linked at the bottom and I will send out this slide so you have the links. But the idea here is that a data analysis, like, when you're doing this kind of consulting work equivalent to the design work with a data analysis, this analysis is only really successful if the audience to which it was presented accepts the results. So like, even if it's technically correct, even if you've done the right math, if you run into that kind of back and forth nitpicking and never resolve it, that analysis wasn't really successful at what it was supposed to achieve, because what it was supposed to achieve was sort of this acceptance and the audience being like, okay, I believe the insights that you have, and I understand the uncertainty, but I agree with your conclusions. And so even if you're like technically accurate, this analysis isn't successful unless you accomplish this goal. And so what I love about this thought kind of, this line of thinking that we did is that ultimately that really comes down to negotiation, where, the language of the negotiation is statistics, but ultimately we were trying to do is get to an agreement, right? That I did this analysis and you're going to believe what I did. And not just because you want to placate me, but like I've fundamentally convinced you, that this conclusion is the correct conclusion, and I've communicated the right level of uncertainty, and we're on the same page, and whatever outcome happens because of it, we're all comfortable with. And so this was a really fun kind of connection that Roger really came up with. And so we went through this like kind of canonical book on negotiation called Getting to Yes, which I so highly recommend. And there's also another book called Getting to Yes with Yourself, which I also recommend. I'll talk about that in a minute. But it was really fun to think about analysis this way. Because the way that I've seen this play out, again, in a tech setting, is that you might have a decision that needs to be made where it's like, okay, we need to know, we redesigned statistics, and we need to know whether to go with the new design or the old design. And so backing up from that, it's like, okay, so, Stitch Fix is a company that's, committed to empiricism, committed to being kind of data driven is how you hear that. And so, sorry, wrong direction. So, when you talk about negotiation, it's like, okay, you want to get to an agreement, a decision that everyone agrees with. And so you have to define like what objective criteria you're going to use to do the decision. So in a data org, in an org where you're doing a lot of A/B testing, you're going to take the two designs and you're going to put them both in front of customers and clients and see which one performs better based on some sort of agreed upon metric. So it might be, okay, we want to know that more people purchase fixes in design A versus design B. And so at a data-driven company, or in a lot of, in scientific settings for sure, everyone is just like, we all subscribe to the scientific method. And so we all kind of agree that these are the rules of engagement and that decisions should be made based on this kind of objective criteria that we establish in a very systematic way. And so if you kind of back up from that, I keep clicking back because I know my graphs are going back. So anyway, that's kind of funny. But so like I said, because as scientists and data scientists, statisticians working in a data-driven company, all of these things, the way that you get to those objective criteria for like, yes, design A was better than design B because design A converted more clients, you run that via an experiment or a survey and you say, okay, we're going to get these measurements. And so again, kind of zooming out, so like this is kind of the rules of engagement. Everyone's like, okay, this is how we negotiate in a company for how we do A versus B, or in the scientific community, how we decide to do A versus B. But there's human consequences to this stuff. So, there are people who have to make these two experiences, and there might be like very good hypotheses for why design B is better. We've taken this experience, we've modernized it, we've changed certain aspects that we think like clients, we know that clients were complaining about. So our hypothesis is that this is going to be better, right? And so, but you can imagine that, I should have said design A there. So design A is better. Everyone thinks it's better. And the person who's managing the team, you need to understand as a statistician and as a data scientist that engineer manager wants design A to win because that gets them more headcount, that gets them more, people on the team, that gets them more status within the company if they've designed this fancy new system. Versus if design B wins, then, that's going to stay the same. And in a scientific setting, you see this all the time with like, yeah, if design, if our experiment works, we get to publish a paper. And if it doesn't, then, that money kind of like went nowhere. Like, you can't publish negative results, all of that. And so because of that, you can imagine it's just like a normal human reaction that you want the good thing to happen. And so you see this kind of like pedantic debating of methods because they're trying to say, well, no, we really want to see design A win. And so what you hear from this field a lot is that you really have to understand your collaborators, people. Like the whole first half of getting DS is just about like understand the people, understand their emotions, and understand, what is going to make their life better versus what is going to make them worse, because that gives you the ability to skirt around these like sensitive areas where it's like, okay, I don't want to tell you all your ideas were bad, but this experiment totally failed, right? And so, I think again, in the scientific community, there's sort of a buy-in that these are the rules of engagement, but it's still really difficult and you still see these conflicts coming up. And then in a tech setting, like people don't even necessarily subscribe to the same rules of engagement, so it's even more complicated. So understanding the people as the collaborators as the people first is such a good tool to have as a data scientist and a statistician, because it means that you can actually get to productive conversations without sacrificing sort of statistical integrity or kind of, fudging the truth and saying like, no, design name is better. I want to get you off my back. So to do this, like, this is like obviously a challenge for everyone, definitely a challenge for me, is like, when you're negotiating, you need to be able to extract your ego. And this is like a huge challenge. And I think in academic settings, people in data science field, like we so many people in this field, like being smart, being the smartest person in the room is important. And like, that's kind of how you've been validated your whole life. And so if someone is telling you that your analysis is wrong, that can feel like a very personal insult, even if it's not. And so learning ways to extract your ego, I mean, it's so unsatisfying. And, you know, I have leaned a lot on meditation and kind of personal work. And I recommend that so highly because it, you know, it's not easy, but you're capable of cultivating as people. This isn't just some sort of fixed character trait. And so, you know, it sounds kind of very San Francisco and New Agey to be like meditate, but meditation really has been a very powerful tool for me for being able to kind of extract my ego, see the other person, understand exactly like why the thing that I'm communicating is upsetting to them. And so even though it seems kind of New Agey, it really will make people better at their jobs as statisticians, data scientists. And then, yeah, like understanding, I'm just going to skip this slide because I'm not totally, oh, right. Okay. This is phrased wrong, which is why. So basically one, you know, very short thing I want to mention too is that another thing that's really important is understanding where someone's at. So like understanding the person as, understanding the collaborator as a person, like that Excel example that I was talking about earlier. So people in finance, they're so used to using Excel. If you ran at them with like the latest fancy interactive visualization that is just totally different than what they're seeing, you will confuse and overwhelm them. So you have to take what they're used to, and you might be able to go a little bit, you might be able to push them just a little bit here, but if you go too far, you're going to overwhelm them. And so that's another difficult thing to do as a statistician, because in this field, we love new methods. We love fancy new visualizations because we've seen it all. We've seen, you know, the different ways of approaching things, and it's intellectually stimulating for us to do something that's really advanced. But then for the consumer, like by definition, they're not in this field all the time, and they don't care as much about what, you know, the latest and greatest visualization tool is. And you're actually doing yourself a disservice, and you're kind of serving yourself more than you're serving them by creating something super fancy. And what that person would be served by the best is something that they know how to digest, and they know, you know, oh, this is something I'm comfortable with, and I see how Hilary added this kind of interesting thing, but it's not just like, this is a foreign language to me, I have no clue, and now I just don't want to talk to Hilary anymore. So I'm just going to skip that one slide. But so yeah, kind of along those lines, it's just like, don't let the fun get the best of you. Like, we all love thinking with data, we love analyzing it. But again, if you're not serving the person that you're collaborating with, it becomes, like I said before, it just becomes much more self-serving, where it's like, okay, sure, it's fun for data scientists to do a super fancy new machine learning method that they just read about or learned at a conference. But if that doesn't solve a business problem, both people are going to be frustrated because you've used this fancy method and it might be intellectually stimulating, but ultimately you were hoping that would get used somewhere. And the issue here is that if you don't serve the business need and you instead do something that's fun for yourself, you'll be disappointed because the business won't use it. And as statisticians, it's like, yeah, maybe you wanted to do this super fancy method for a new publication, and you know, it's something that's totally different than what the field is expecting. But then what you'll run into is that the peer reviewers will be like, why did you do this fancy thing? Couldn't you have done this other thing? Or, you know, you'll just run into that communication barrier, and it'll be really unsatisfying for everyone. So in the last 5 minutes, I just want to give, you know, some practical advice for like, okay, hopefully I've convinced you that these fields are important. And, you know, I really encourage you to kind of dig into the literature where you can. But now I just want to talk about, okay, so like, what practically can you do as teachers in order to bring this, you know, bring students along in this? And so the first one is just that design isn't this like mythical, mysterious thing. You know, there's sort of this idea of like brilliant designers and what they've done, but actually it's something that you can cultivate and you can grow. And when you look at the design thinking research, they have tons of examples of different ways that they've empirically measured that this is a capability that you can hone and develop over time. It's not just like a innate character trait. And I really love this quote from Nigel Cross, where it's just talking about, you know, this is a third way of knowing. This is a third fundamental dimension of human intelligence. You have design, science, and art form this and not an or relationship to create our incredible human cognitive ability. And so with data science, you kind of have the science down, right? The art comes in with like kind of the way you present graphical visualizations, but this design part is, I think, the one that we've been fumbling at trying to understand better. And so, yeah, I'll just leave like kind of this, it's kind of like this brief list in the end of things you can do. But one of them, you know, looking at the different design research and how you train architects, et cetera, you know, encouraging students and yourself to consume and participate in the things that they're engaged in. So if you're doing, like for me, it meant that doing data science around fashion meant, you know, me thinking about fashion more, me reading fashion books, me watching YouTube videos of people unboxing our fixes. Like those are all part of this system that I'm working in. And the more I understand it, the more quickly I can iterate on solutions. Another one's purposeful practice. So actually practicing building an entire system. So like, you know, I give an example that Joe Hardin's expanded on a bit of like, you know, if like a way of understanding how to sort of build this entire statistical framework would be to start with, okay, we want to do a data analysis. So you, Hilary, go out, collect the data, get it into your, you know, like whatever software you're going to use, get it into some sort of existing thing at the end. So an example of that would be, you know, measuring your commute time. So it's like, okay, if I want to understand how long it takes for me to commute somewhere, I can start by understanding, you know, how would I even measure how long it takes for me to commute? And then how would I analyze that data? How would I store it? And ultimately, how would I present that to myself in a way that I can digest and understand? So setting students up with an example, like a project like that, where they actually have to collect the data, can be really good, kind of the way you have architects learning how to build things by just going and building them. This one sort of in line, the last two are kind of the same. So giving your right brain space, that kind of creative center within your brain, and then like empathizing. This is going to be the most difficult for people because it's so different than what, you know, math and science training is usually like. But like allowing students to really get creative with things and making it kind of psychologically safe to do that. You see that with the Blameless-postmortems and coming up with interesting solutions. And then also, again, like meditation, having people just like literally do art, like getting playful around creativity, that sort of opens up the kind of mental space you need in order to start using this design center of your brain. And, you know, again, I encourage you to look at the literature for this field, because you see things like people with the split brain, their right's disconnected from the left, that really hampers their ability to do design thinking. And so, yeah, cultivating empathy, this last point, is just, again, such a key part of it is negotiation. Such a key part of it is understanding other people. And so going through that practice of getting students and people to understand, you know, let's think about the incentives that this person has, and let's think about how this news is going to hit them. I think that'll just serve people really well for this career path in general. So with that, I have it right on the dot. I guess at 5 Eastern time, 2 o'clock here, but.
So you mentioned getting the data is the most time-consuming part of the job. I understand and have heard this from other practitioners. From a job responsibility perspective, while the survey is being filled out, the sensor's collecting data, customers are answering questions. What is a data scientist engaged with?
Interesting. So yeah, so I guess what I really encourage people to do is to get involved with that process. So for example, I am in the room with the engineers and with the, you know, other collaborators as they're designing these systems for collecting data. And so the more that I can get my hands dirty and understand exactly how they're building things, the more fluid this conversation is. And so I bring up the example of us building out that style shuffle game where you rate clothing, because that was a really good example of, like, in that case, the data scientist was literally, you know, making the data collection tool itself. So the more that you can collaborate on that part, the better, in my opinion.
So you are fairly active in that component.
Yeah. And I think, as like working in a scientific field, I know that one of the statistics professors I worked with, he actually spent some amount of time in a wet lab, just like actually running the microarrays at the time and understanding, okay, like, oh, I understand now that this bias is introduced in this way. So I really heavily encourage that. I think that's something that a lot of data scientists and statisticians are resistant to, but I think it's a huge part, a huge boon to do that.
To get that experience. So kind of along with that, we have another question. Suppose I'm advising a data science student. What second major or minors would help develop the design aspects of the student's skill set?
That's a really good question because, yeah, I mean, it obviously depends on the field you're in. And so I was, the school you're at, and like what sorts of things are even available. Because now data science like exists everywhere. So it's like that blows my mind from even, 15 years ago. But I mean, honestly, like, gosh, it sounds so hippie, but like even just like art, I know that's crazy, but it's like being more exposed. Like, to me, the thing that's helped me the most in my career is like accessing that side of myself more. So like understanding how artists think a little more, intuitiveness, or like architecture, building things, doing, sculpture classes, making stuff from nothing. Like any sort of thing where you're building things, or frankly, yeah, like projects, like literal architecture projects, like how would you build out the cafeteria, like it's hard to know without knowing the academic fields, but yeah, like really elevating kind of these creative fields. And this is easy coming from Pomona, liberal arts, but it's like elevating these creative fields and communicating the connection there, I think will go a long way. So yeah.
Very, very interesting. So in design thinking, more along those lines, there's a principle to engage stakeholders early and often. How do you brainstorm who makes up that stakeholder group?
Yeah, so that's a really good point, that especially in a classroom setting, it might be a little bit harder to come up with a stakeholder group. And, for me, it's like these things just fall in my lap because it's like the business, right? And so actually, I think making the students themselves the stakeholders, I think, is really important. So I mentioned that commute time thing, but you could probably have students come up with questions. And I actually know that Joe Harden and a collaborator whose name is totally slipping my mind, like tried this in a classroom where they did something with like Google Calendars and like how much free time do you have in your calendar. And so like having a personal connection to yourself is like a very easy stakeholder, where it's like, I am the stakeholder. And then I think they actually did something where they would like cross over and be like, okay, now like you build something for this other student. And so potentially making the other students the stakeholder, I think would go a pretty long way for that. So hopefully Joe doesn't feel like I scooped her or anything, but like I was so excited when I heard that they had done that, because it was, creating other students as stakeholders, I think is a really cool solution. So
good. So along with working with students, when you're hiring people, what skills are you looking for those students to have in the job market?
Yeah, so that's the fuzziness of this term is does not serve the field well. So it really depends on the job description. And usually the best clue for it is from the tooling that are mentioned in the job listing. And so that's really difficult, where it's like, oh man, I can't say for a generic data science job what's needed. But in general, I do think that there's industry level tools that you just don't see people getting trained in that much, although that's coming more and more. So SQL is one of the biggest ones, where it's this like kind of very standard data management. I don't know. It's like a very common way of being able to access data. So that one's really huge. And then I mean, yeah, I wish I could answer this better, but I think that students coming in with practical applied experience in R, I think that having them do projects that they can kind of expose and, you know, tell, so like having people put together GitHub repositories or blog posts or whatever with like, hey, I did this analysis and here's how I thought it through. I know that for me personally, having some visibility in the way I thought about analysis really helped me get my first job. So I think, yeah, showing the practical, the fact that students can practically apply this might be the most important for that kind of first job.
So what are your observations regarding the training statistics students receive or don't receive on topics pertaining to the data collection piece of the process?
Yeah, so that's definitely the most efficient. And so I think that, you know, it's funny because I gave a version of this talk to a bunch of biologists and I was like, oh, that's like actually really easy for them to like think about this aspect. Like I didn't have to pitch the idea that data collection was part of the job because that's what they do is collect data. And so, oh, I lost my train of thought. Can you just say the question one more time so I make sure that I'm answering it right?
Let me go back.
Sorry.
No, it's okay. What are your observations regarding the training statistics students receive or don't, right, pertaining to data collection?
No, I think that this is a real deficiency in general. And like the kind of like Kaggle and things, like there's kind of, if anything, the kind of public things that people can participate in, like discourage it even more. And then you see a lot of like web scraping for data collection, but that's like only one thing. And so, yeah, I would say that in general, you don't see a lot of that from these types of programs. And I think it would be good to, I don't know, have it. So actually, you know, I feel like some people who are much more incentivized is almost like political science students or economic students who, like I have someone from a more kind of political science background who actually built this kind of like betting site, not like actual gambling, but it was like in order to understand how people were thinking about future events and like, you know, kind of gamifying that into like some like fun, like kind of betting stuff. And so then that was a data set that he like created technically and then could explore. So yeah, you don't see it much.
Okay.
What I'm saying.
Yeah, okay. Unfortunately. So one last question because we are over time. So you've talked a lot about the style options, but how much do you take into account the price of the items? So personally, I might like all the items, but I couldn't afford to get all of them.
Totally. Yeah. And that's something that we are continually thinking about for sure. So yeah, like this person is right that kind of the solution I said for more data is just along the lines of more style data. And so right now we're still limited by that kind of small data problem where it's like, okay, we only understand someone's price preference based on the feedback they give. And so we do some matching based on their surveys and, you know, this is actually where the human in the loop comes into play a lot because people are, as you can imagine, very vocal if something's too expensive for them. And so that's actually where the humans really like make up for deficiencies in the model where they're like, okay, I know just how much I made this person mad by sending them something that was too expensive. So I'm going to really make sure that next time I don't. But again, ideally we would be modeling all this. And as we're getting into a little bit more of like consumer shopping, which is, you know, some more recent stuff on the site, we're getting a better understanding. We're going to be able to develop more sophisticated things because, yeah, this is obviously a huge part of fashion. So,
right. And price does play a part in that as well. Yes.
Absolutely. Yeah.
Well, thank you so much for bringing these ideas for us to think about and how we can bring some of these ideas into our classrooms with our students. We really appreciate your time. Thank you.
Yeah, thank you so much. And thanks everyone for staying a little late. So appreciate it.
Thank you.
All right.